So if you look at your sheet, can you give me one example of something that has a GCF?
Number 3.
Number 3, okay, let's look at number 3. And for number 3, 120A. For number 3, all we're going to do this time is the GCF, and then we're going to do the rest of it in a minute, okay? What is the GCF here? What do they all have to give? 5A. They all have an A to give, and they all have a 5 to give. So if I pull out a 5A here, and what's left is A squared, because I pulled out the 5 in one of the A's. I have minus 2A. I pulled out a 5 in one of the A's. And minus 24. Okay, so that's how you factor out the GCF. Now in this case, A squared minus 2A minus 24 goes further. And we'll look at that in a second when I go to the next step. So the first thing you're going to do is pull out the GCF, if there's one. You've got circle GCF. Put GCF next to which numbers? All right, the difference of two squares is if you square rooted each of the terms, there's only 2 terms, first of all, and if you square root both of them, you get a perfect square. So let's say I have 16A squared minus 9. What is the square root of 16A squared?
4A squared.
Just 4A.
Or 4A.
And what is the square root of 9?
3.
3. So the 2 parentheses are going to be 4A and 3, one with a plus and one with a minus. That's how you factor those. The square root of 16 is 4. The square root of A squared is A. The square root of 9 is 3. If you FOIL that back, you get what you started with. So if you ever get stuck and you can't remember, just FOIL back what you think the answer is. So we took out the greatest common factor of 4K, and we were left with K squared plus 7K minus 8. Now you have to ask yourself, what times what is negative 8, and added together is 7?
Oh, this is the X thing, right?
Mm-hmm. And some of you did this thing up like this?
Mm-hmm.
Yeah, I don't do that, but I just do what times what is negative 8, and added together is 7. Anybody have any answer? When you look at your leading coefficients, if both of them are perfect squares, the last term and the first term, so this is a perfect square and that's a perfect square, try that first because that might get you out of trouble without having to multiply stuff and do it the way I'm going to teach you on number 19. So here, 9, the square root of 9 is 3, the square root of I squared is R, and the square root of 25 is 5, and then we have 3R and a 5, right? And now since it has to be negative in the middle, they both have to be negatives because they have to be positive when you multiply and negative in the middle. You understand that? So now, usually, we know we've got the first term, 3R times 3R is 9R squared, and we know we've got the last term, negative 5 times negative 5 is 25. So let's just check and make sure we have that middle term. That's a negative 15R, and that's a negative 15R. So that becomes negative 30R, so that is correct. Okay, so if you see that they're perfect squares, those are usually perfect square trinomials. They don't have to be, but they're usually. If it doesn't work where you don't get the middle number, then you have to do this next thing that we're going to do on number 19. So we have 5x to the 4th minus 32x squared minus 21. Okay, the first thing we're going to do is multiply the first and the last number. So it's going to be negative 105? I think it is, yeah. Negative 105. And we're going to say what times what is negative 105? And added together is negative 32. So if you find different ways, what I do is I count up and I say what numbers go into negative 105 and make a list and then look to see which one of those adds up to negative 32. So now we're going to rewrite that equation and we're going to take this out, and we're going to use negative 35 and 3. So it's going to be 5x to the fourth minus 35x squared plus 3x squared minus 21. I have replaced the negative 32x squared with a negative 35x squared and a 3x squared. They add up to the same thing, right? I've just split them up because I found those numbers right here. Now I'm going to put parentheses around the first two and the last two and pull out a GCF. So here I can pull out a 5x squared, and I get x squared minus 7, right? And here I can pull out a 3, and I get x squared minus 7. So I have 5x squared plus 3 are the two that are left out in the cold become the first parenthesis, and the second parenthesis becomes the x squared minus 7. Look at this.